This video is a recording of the NDS Association webinar held on February 25th, 2021 about what is NDS.Live.
Let's go. Hello and welcome to the NDS Association webinar. Today we will answer the question, what is NDS.Live? And I admit that's a fairly broad question. Before we look at the agenda of what we're covering today, allow me to promote the video recording of our webinar about the advantages of NDS.Live for intelligent speed assistance. We did that on February 4th, and the slides and the full recording of the hour-long session, including our panel of experts, is online. To see it, go to the NDS Association website at NDS-Association.org/NDS-Live-ISA-webinar. You can see the link on the slide as well. Like last time, this webinar will also be recorded, and the video of today will be shared on the NDS Association website and YouTube channel. Once available, we will make a post on LinkedIn and on our NDS Association website. This is the second of our four-part webinar series on NDS.Live. On March 11th, we will talk about how to reduce data consumption in connected cars by using NDS.Live, and on March 25th, it's all about layering map data by Freshness and use cases and delivering them the smart way to cloud systems and vehicles with NDS.Live. Please join us again on these dates. You will find a link to register in advance of these sessions on the same NDS Association website page with the video recording. The first webinar we'll post on LinkedIn. We'll have news posts on our website with the registration links, usually about 2 weeks before those dates. And now with me today is Fabian Klebert. Fabian is the technical coordinator of the NDS Association and CEO at Klebert Engineering. And my name is Philip Hubertus. I'm a senior product manager at HERE for automotive products and map applications. I hope you're sitting comfortably with a tea, coffee, water, or juice nearby for the next 60 minutes. And here is an overview of what we'll cover today. First, I will share a bit of background on where we come from and the changing market needs that led to the evolution from NDS Classic to NDS.Live. And then I will hand over to Fabian, who will talk about the basics of what NDS.Live is, the design principles, smart layers, the modularity along features, and the tools that are available supporting NDS.Live development. And then we have reserved time for your questions. You can ask them anytime in the Q&A box. And then we will select you to ask your question live, and ideally with your video switched on. If you at all don't like that, but you still like your questions to be answered, and you can simply make a note in your Q&A question. Great. So NDS is short for Navigation Data Standard, and it is the worldwide standard for map data in automotive ecosystems. NDS maps work worldwide and are globally adopted. NDS members and map coverage include North America, EMEA, APAC, including China, South Korea, and Japan. NDS offers a well-defined spec for how to store map data, and it allows flexibility for customized user experiences. The NDS specification covers the data model, the storage format, interfaces, and protocols. And NDS is really designed for in-vehicle navigation and for ADAS and e-horizon safety systems. It is for mobile companion apps, connected car, cloud solutions, and for automated driving. It evolves with the market needs, as NDS is for the automotive industry by the automotive industry. The NDS Association was founded in 2009 by OEMs, application, service, map data, and compilation providers. And NDS-based products are available in the market since 2012 and used globally in ADAS and infotainment systems, and development on the OEM side is well underway to use NDS for level 3 driver automation. Over 30 OEM brands are using NDS maps today in their in-vehicle systems as well. The advantages of an industry standard like NDS is that it creates this broad consensus in our industry on the best path forward. And it's made by the best engineers and experts available from multiple companies. You see a list of all of the members here. Some say that standardization consortia may not, are not known for a fast pace. However, market-driving associations by like-minded companies, as it is the case with NDS, demonstrated to have the right speed for the market. And that is really what we're going to talk about today. What is NDS.Live and how did the NDS Association member companies came together to define the evolution of NDS for connected cars? Let me talk a bit about the market needs. Since NDS map data standard was first introduced, the technology has evolved tremendously. Map data needs to be much more detailed, precise, and fresher to support assistance, navigation, and automated driving functions. New use cases for map data are appearing left, right, and center. Cars are now equipped with data connectivity. Map data can be updated and even streamed over the air. And selected features are powered and delivered by cloud systems. Not everything is done by the in-vehicle system any longer. That means map data needs to work on cloud system and on in-vehicle systems alike. And what is also happening is that the automotive platforms span over more and more models as OEMs are looking for greater scale and cost efficiencies. And electric vehicle platforms will only accelerate this trend. So what that means is that the features needing map data span from fairly basic universal features that need a road network to more specialized features. So for example, from intelligent speed assistance to ADAS, to basic navigation, to advanced navigation, premium navigation, and up to drive automation. And with reducing the number of systems and ECUs down to one, that is one trend, we also acknowledge that bringing different data sets with overlaps of map attributes into vehicles doesn't make sense from a cost and data management perspective. All that data has to travel over a data connection, which creates cost. A modular approach is needed. That allows map data layers to be consumed by cars according to their active feature set, while the architecture of the underlying system scales across the entire portfolio of features. And then there is data that has a very different shelf life. Some of that data doesn't need to be updated often. Map display data like hardware features, 3D landmarks, or a digital terrain model are examples here because they don't change that often. But some of that data does change more often and needs more frequent update. And there is data that you need in near real time and the system uses it only once. So understanding data shelf life and offering ways to consume and store data differently has a big impact on data consumption, data transfer costs. Reuse what you can, keep dynamic and live data in as small as possible containers. And with NDS.Live, the specification now supports these new requirements and use cases. And this combines the best of our experience with today's realities and tomorrow's new possibilities. And that is why we say NDS.Live is not a database. It is a distributed map data system. So NDS.Live is essentially the worldwide standard for distributed map data in connected automotive ecosystems. It is built on the long experience of leading automotive OEMs, system vendors, and map data providers. 2 years ago, the over 40 NDS member companies started looking at the evolving needs of connected cars, where software plays a major role in the consumer user experience. And what is clear is that in our globalized market, with its modular and scalable architecture, with embedded and cloud-based systems, with driver assistance leading to driver automation, we need to properly support all this in a better way than possible with the NDS Classic specification. And that's why we came together. Modular and self-contained, that's what NDS.Live is, to minimize data consumption, downloading and caching data, and enabling both embedded vehicle software and cloud systems. NDS.Live was officially launched last year in September at our NDS public conference, and several NDS Association member companies are actively developing this to be production grade this year. Fabian has been key to the definition of the new specification and driving development forward together with the NDS members. And I'm handing over to Fabian now and let him talk about the details of NDS.Live map data services.
Okay, hello. Thanks, Philip, for having me. So also a warm welcome from my side. So in the next couple of minutes, I'll try to give you some more insights into NDS.Live from a technical perspective and dive into an example scenario. So lean back, relax, here we go. So when we started out designing the next generation of NDS, we took a look at the consumers and sources of map data. So in the past, only navigation systems needed map data, and that came primarily from map data providers like here, TomTom, NavInfo, AutoNavi, and the likes, right? So, but in today's world, a lot more consumers need map data, and they need more map data than in the past. Where in the past, ECU would only need a speed limit, today's autonomous driving systems need a complete HD map. So with NDS.Live, we aim to reduce the transcoding and the back and forth conversions of map data along its way to the consumer. And this is why we say that NDS.Live is the one language of map data for the whole ecosystem. So whether it is B2B or B2C, whether it is from cloud to car or within the car, map data doesn't need to be transformed into any other formats any longer. That's the idea. So getting rid of all these conversions of the past does not only reduce the complexity of the whole system, it also contributes to improved functional safety. So yeah, we said we want to cover everything. Yeah, sounds smart, but how to do that? So how could we move a physical storage format, which NDS was in the past, or better still is with NDS Classic being out on the road and millions of cars at this very moment. So how could we move this physical format over all these different parts of the ecosystem? A physical storage format would not suffice here. So we needed to move on. And instead of being a physical storage format, NDS.Live now defines service interfaces. The map data encoding is still at the heart of NDS.Live. So it is shipped via standardized service interfaces in flexible data layers and predefined data containers. Yeah, the key takeaway here is that NDS.Live is not standardizing an on-disk format any longer as we did in NDS Classic. So we had to climb up one step in the application stack ladder to be able to satisfy the requirement that we can run on any system and be transported over any wire or wave. So we'll talk about services in more detail in a minute, but let's quickly focus on some other important aspects of NDS.Live first. To be able to create a future-proof standard for an ever-changing ecosystem, we first needed to tidy up our own room a bit. So based on the lessons learned from NDS Classic, this time we went for a highly modular approach in NDS.Live so that we can enable developers to migrate quickly to newer versions of the standard. And since the target was now a complete ecosystem, it was also clear that not everyone would probably implement the complete standard anyhow in one system, right? So it was important that developers can focus on a minimal set of modules they need to implement for their needs, and that the standard can be involved in certain areas while keeping some other basic areas stable for a long time. So this all leads to higher development speed, a lower time to market, or in case of a standard like NDS, a lower time to standard as well. So that is extremely important in a market where other non-standard competitors are offering similar end-to-end solutions. So, and the value of a standard decreases heavily if it simply comes too late. So with that in mind, let's turn to the most important concept in NDS.Live, the NDS.Live Smartlayer. This concept is like the key to the mansion on the hill of map data delivery. The Smartlayer service distributes map data layers, simply said. So Smartlayer is the concept for all the data containers in the NDS.Live. Smartlayer can be configured to meet any kind of needs, right? It can hold data optimized for a special use case, think ISA, data tailored for a car brand, fleet data. It actually can hold anything. So as long as it's map data. So it can be pre-compiled, it can be generated on the fly, it can contain any kind of static data, dynamic data, live data. So you remember the image that Philip showed about the data needs and the data freshness just a couple of minutes ago? The matrix with the construction sites, the indoor parking and all of that. So actually all this data from that matrix goes through Smartlayer services in NDS.Live. So think of this, Smartlayer services, they provide the door that most NDS.Live data walks through. So no matter who walks through the door is always the same. So same height, same color, same doorknob, etc. So if you joined the first webinar, you may remember this picture. So it shows from a kind of galactic point of view how to scale smart layers along car lines or functionality. So simply said, stack together data layers and keep adding more for increased functionality. Sounds simple. So why don't we make such a buzz about it? Because if done right, this solves a lot of headaches that you usually have to bear with when compiling map data for a variety of consumers. They usually all have their tiny differences when it really comes down to how they need their data served. It's a similar game like running a restaurant with a variety of customers. So you do want standard as much as you can, but you still want to serve individual experiences to your guests, right? So, but you still want to make a buck, and there's no time to cook everything from the very beginning, because that would mean either less guests or more cooks. So this is what you do. You serve standards with a little extra here and there, right? And back to map data and smart layers. So you simply add a thin customized data layer for customer A on top of the standard layer that you ship to everyone else. So yeah, by the way, you can't really see that from that picture that we're showing right now, but I hope you could follow anyhow. So yeah, I told you already, smart layer is kind of concept more than an actual data container. So it's more or less, better said, it's a concept for all NDS.Live data containers. So let's take a look at what these containers are then. Smart layer data in NDS.Live is packed into 3 different data containers. So it's tiles, paths, and objects. And these data containers, they differ in the spatial extent that they're covering. So map tiles, I don't think I need to explain much here, right? So for the ones familiar with the NDS tiling schema, we simply reuse the famous one from NDS Classic with a little difference that in the tiles are now fully self-contained in NDS.Live. So there are no references to other tiles and such. So paths, they're simply paths along a road. So basically all data along a certain stretch of road, which will also include the road data or geometries itself. So not only attributes, right? So the complete smart layer stack you're getting also for paths. And objects. Objects, they don't have any predefined spatial extent. A good example would be an indoor venue or a parking garage. So there's really no added value to store that in a tile approach. So this is why we added objects. But again, the same as in all other containers, the content is layered following the smart layer approach. So there's still some other data in NDS.Live that will not fit into any of those containers. So especially data from application services. So for instance, a route, a horizon, some metadata. So that is then additionally defined beside the smart layers. So, but there are basically 3 terms we need to remember from this slide: smart layer tiles, smart layer paths, smart layer objects. We will need them later for the example. So now that we have tiles, paths, and objects, we also need to understand that they're all used for any kind of data lifetime that we transport in NDS.Live. So the concepts and data encodings, they are the very same for static, dynamic, and live data. The only difference is basically the lifetime information in the smart layer header. So static map data has version information, such as a version number. Dynamic data has age information. So that means how old is the data, when was it collected, and what's the expected expiration date. And live data is, yeah, simply live. So it doesn't have any more information than being live. So let's summarize smart layers before we move on. We learned that smart layer container, which can be a tile, path, or object, has 1 or multiple data layers. So those data layers can contain either static, dynamic, or live data. It can also be mixed. So not the data layers can be have mixed data, but you can mix data layers of different data lifetime in one smart layer. So the containers, they basically differ in geospatial coverage, and they all follow the same inner layout. So basically being a list of data layers with enough metadata for an application to know what to expect. Important to note here is that the data layers, they're all defined in separate modules of the specification. So this is where the modularization kicks in, right? These modules, they may have different versions of the specification and all of that. So, and at first glance, if you take a detailed look, this may now confuse a little, right? But trust me, there's enough magic in the metadata and the smart layer itself that this works flawless across different versions of modules. So we want to share some of the magic, maybe in one of the upcoming webinars. For today, that will be too much. Another important note is that there is only one configuration of smart layers valid for one service. So you need multiple configurations, simply spawn a new smart layer service, as simple as that. Okay, so now that we know how to pack together all kind of map data in a smart way, so we'll need to see how do we get it across to the consumers? Yeah, when I showed you the first slide, you remember there was like that little NDS.Live icon on every communication channel available. So I told you then that we went from physical storage format directly to service interface. And that basically leads to the question, which transport protocol we use for all these services? So the answer is NDS does not standardize this. Reasons are simple. There are many suitable transport protocols around, right? To define a standard that includes all of them is not really feasible. It's not a feasible thing. And to make a bet on one specific transport protocol, even if that is the most commonly used today, I mean, it's still a bet, right? So you can lose that bet tomorrow. Especially when you take a look on transport protocols inside cars. You simply need to be able to run on top of any custom protocol. So that is why we designed NDS.Live not to rely on a certain transport protocol. But we also acknowledge that leaving out this answer is not really helping in developing an NDS.Live based system. So we have introduced a layer in between the transport layer and the NDS.Live service layer. We call it the reference layer. So where we actually choose commonly used transport protocols like HTTP REST and provide reference implementations for those. We can see that in the next slide. But before we go, we remember NDS.Live runs over any web protocol and over any in-car protocol. Let's take a quick look on the architecture behind what I just explained. So NDS.Live defines the data encoding in separate modules. So they all get served via the NDS.Live service layer. And then the reference layer translates the NDS.Live services into other common service documentation standards, like, for example, the Open API spec for HTTP REST. And then the implementation plugs any desired transport protocol underneath. So again, from a developer's perspective, NDS.Live uses Serial, a schema IDL similar to protobuf, to describe the services and data. Zero generates code either in Python, Java, or C++, and this code contains then one or more service interfaces, which then are to be implemented with an underlying transport mechanism. And for references like HTTP REST, for instance, we offer reference implementations that are ready for use and can be easily adopted. So before we move on to an example scenario, let's keep in mind that NDS.Live provides interoperability on the service layer, on the service level, right? So regardless which underlying transport protocol is used, in the end, the application will receive a serial encoded object, for example, a smart layer, and will be able to work from there without having to deal with the channel that the data was received through. So, right, but now that we have everything we need under the belt, let's roll an example. Okay, that may look a little overwhelming at first glance when we're looking at this slide, but yeah, one of the downsides for these online webinars is actually I cannot see any reaction from you guys at this. So I guess that even if you followed closely, at least you now may say, what is this? So let's decompose this a little, right? Or let's start all over a bit. So we start with one map compilation party on the lower left. That map vendor wants to feed data to two different car brands or OEMs. The important thing to note is that they have different requirements, different hardware running, different onboard cache size, different system, everything's different. So how does NDS.Live help in such a scenario? So let's talk about the options. But before we do that, our compilation party simply wants to produce map data, right? In our simple case, map tiles for 3 different layers. Could be road, could be ADAs, could be speed limits, could be anything else as well. So the map compiler, what the map compiler does, it first drops data layers one by one into what we call a data layer store. So please note they're not yet stacked yet. So we're doing this in the next step. In the next step, we need to check the requirements from the blue and the purple car. So where the blue car only needs 2 layers, the purple car wants 4. So for the sake of space on the slides, I've omitted the 4th layer on the data layer, but this shall not confuse you now. So instead of 2 separate map compilations for the blue and the purple car, we simply stack the map layers to smart layers based on configuration options. And all of a sudden, our data is now ready to be shipped from the cloud to the car. So for this, the car queries a smart layer service, which is in this example implemented as a HTTP REST service. So the blue car stores the tiles of its surrounding areas in a small map cache, and the purple car forwards more data to a smart map cache using another protocol. In this case, we took just simply gRPC. The smart map cache system may implement also fallback map or other smart solutions. The main reason why we added it here to the example is to show that the local map server in the car may reside on a different device in the car, which may need to be addressed via another transport protocol than the one we received the data for. So important to note is that the encoding of the smart layer tile has not been altered on its way, right? Even that it traveled over HTTP REST and then over gRPC to reach the smart map cache server in the purple car. Now, in the last step, we ship the map data within the car to the end consumer ECU. In the blue car, we unpack the received tiles and cut out paths and serve these internally using, for example, DDS RTPS. Unpacking from tiles to path involves copying the data. It's yet without any re-encoding to another format. And in the purple car, we do the same for a small ECU, but we also find a bigger system there. For example, an automated driving unit, which directly consumes tiles. So we ship the unchanged data layers, so only 2 instead of the received 4. So this time our car communication runs on custom protocol, right? But as we learned, that's not a big deal. Simply piggyback the NDS.Live layers on top of your transport protocol, you're all set. Yeah, I hope this example explained a little how NDS.Live Smartlayer services can work. I mean, if you have any questions, you probably have them. Simply hold on for a while until we do the Q&A. But before we finish this here, you may ask, what was this whole ISA webinar thing about? Is this just clickbait? Didn't this webinar series say how NDS.Live can help with ISA and so on? So yeah, you got a point. So let's roll another example. This time, possible ISA scenario with NDS.Live. Let's draw some possible services that we may need for this. So please note, it's just an example how this can be done with NDS.Live. Other setups may work as well. So in this scenario, we have one application service for horizon generation. We call it Horizon Assist on the upper left. We only use it initially on startup and maybe once in a while. So continuous horizon calculation will be done locally in the car. So think of it like assisted GPS, right? Then we have 2 options for the static road geometry and the speed limits. So a smart layer tile and smart layer path services. We don't need both in real world use case probably, but I simply added the 2 options in one picture here. So, and then we have a smart layer path service with dynamic speed limit information from gantries or other, etc. And of course, our beloved little blue car. So let's turn on the engine and see what happens. So we are in the middle of nowhere. We don't have any map data cached so far in our blue little car. So we send our current car position plus heading information to the Horizon Assist service. Alternatively, we could have also simply fetched a number of map tiles around us, but we want to save some bandwidth and money since our little blue car doesn't want to waste megabytes from its monthly data plan. So the Horizon Assist service answers with a probable horizon, and we're ready to download some more data for this path, so for the paths in the horizon, right? So you may ask now, how do horizon and tiles and paths all work together? Simply put, horizon, simply a list of paths, And based on the geopositions, we can simply calculate in which tile we are. So let's fetch some speed limit data. Depending on which options we choose, we now query the Smartlayer path service directly with one or more paths from the horizon we received. Or we calculate the tile IDs from the horizon and fetch complete tiles for a corridor. So the blue car now knows all the static speed limits ahead, and it has downloaded enough road geometry data to do its own map matching and horizon tracking. For dynamic speed limits, we have chosen to offer them only along paths, not for complete tiles. So the car queries the dynamic Smartlayer path service for frequently changing speed limits. So this service may run at a different service provider. The path is basically map version agnostic, so that's all possible. So now that we have all the speed limits and the road data available for the upcoming road, and our little blue car is happily driving into the sunset. The head unit, or the general data receiving unit we have there, delivers the speed limit information to the ECU by simply sending a Smartlayer path with all the speed limits. Now with mixed content, static and dynamic, it did put them yet in its own one. And while doing this, it also continuously map matches the data in the cache and generates its horizon. So once in a while, for example, it may have lost mobile carrier connection, it could not update its corridor, it will call the Horizon Assist service in the cloud again to get the freshest data. So yeah, that's basically it. So I hope you enjoyed this examples. But before I hand over to Philip again, one more thing. Some final words on NDS.Live from my side. So NDS.Live is not only a specification written down in lengthy documents. So the NDS Association also supports the development by a dedicated tool, which we call Live Lab. It's actually Python IDE on NDS.Live steroids, so including a map viewer and all that. A developer portal is carrying not only documentation, but also a growing source of tutorials and best practices. And I already mentioned the reference implementations before. And in addition to that, also the NDS Association also offers sample maps to its members to speed up the development there. So yeah, having said that, I think it's now time to head over to the Q&A. Hope you enjoyed the webinar as much as I did, and I hope we'll have an interesting session now. So thank you, and back to you, Philip.
Thanks, Fabian. Yeah, we're now going into the interactive part of our webinar. If you have questions, please submit them in the Q&A window. We'll then ask you to ask the questions to our panel of experts. On this panel of experts, please welcome Otto Nebel, Product Manager at NNG, Danny Sulz, Product Leader at Navinfo, Nico Glorious, who's a Product Manager at Navinfo as well. And then we have Fabian, of course, Technical Coordinator for the NDS Association. We have Boris on the panel, Senior Manager Engineering of the Automotive Publication Team at HERE Technologies, and he's also Technical Chairman of the NDS Association, and myself, Philip Hubertus, Product Manager, Automotive Products at HERE. Yeah, as I said, you can be on the panel too. Submit your questions in the Q&A box, and we'll add you to the panel, ideally with video, and then you can ask your question if you at all don't like to be on video and asking it yourself. Please don't hold back. Ask your questions. We'll read it for you. I'll stop sharing the slides now so we can see more of our panelists. Yeah, good. So, Fabian, do you see first questions?
I don't see any question. I hope
no open questions yet. So
you can also simply raise your hand, and we'll take you into the session here. So either you type it in the Q&A box or raise your hand. Okay, we have the first one here.
Volker, welcome, Volker.
So let's see. We're having also Takatoshi Shimizu wanted to raise his hand to ask a question. So
You bring Volker up. Volker Hiestermann, he's...
It would be great if you guys could simply use the raise your hand.
Can you hear me now?
We can hear you now. Welcome.
Okay.
Hi.
Thank you. May I see again that ISA slide again, that ISA use case slide, showing that base tile and the dynamic tile, dynamic path.
Okay.
And
yeah. Philip, can you show that again? I think you have.
Yeah, let me share my screen. Second get sorted here. So this is it. I need to move the Q&A a bit to the side. So, which one was it?
Yeah, that one. So, smart layer tile and smart layer path. I think that the tile is kind of the actual that NDS like tile, and the path is like horizon. But what's actually the difference between tile and path at that case? The load and speed limit tile and load and speed limit path.
Yeah, I mean, if I can take this question. So the idea is, so the tile is really a predefined map tile. So you're getting all the speed limits. So even if you let's take an example. We're traveling one road through that tile, right? It's a map tile of 1.2 kilometers by 1.2 kilometers, and we're driving only one road through that tile. And if we download the tile, we're getting speed limit also for all the side roads, all the other roads in that tile. And the path basically only gives you back the speed limits for that road that you're traveling on. So that is then that is the major difference between tiles and paths.
And tiles are what? They're 2 by 2.5 kilometers, about that in size. So imagine you drive through a very dense urban city. But on a motorway, so you may just need the motorway speed limits and not all the speed limits of all the surrounding dense urban area. It saves you a lot of data bandwidth because you only get what you really need and consume. So
this case scenario that there are based on the position, vehicle position, that the server side, the horizon assist calculate the most probable path and respond back to the vehicle. Based on the MPP that either that the tile or path is downloaded for that for vehicle to get the future speed limit information.
Yeah,
that's correct. Understand?
Yeah.
And okay, so at that case, that dynamic information is only path, based on that MPP that calculated by the cloud.
Yeah. But that was only the example, right? You could also offer dynamic speed limits for a tile. So I simply didn't want to put too many options in the slides here.
Okay, get it. Thank you.
Okay, thanks.
And maybe while we are looking at the slide, I'm sorry, Philip.
I'll bring it back, no worries. Give me a second.
I think, Fabian, you explained how the tiling scheme of NDS look like, and I think it's quite clear how such a tile is requested. But how is such a smart layer path requested? So how does the request look like? Is it like OpenR or something like that? And there's a second question then afterwards. So for a tile, I know where I am, so I know where the tile ends, so I'm using it as long as I'm inside the tile. And what about the path? So am I requesting a slightly shifted path every couple of seconds, or is it more like well-defined objects from one intersection to another or something like that? So
it's more like the later one. So so especially when we're using something like the horizon assist, you don't send that every second, right? That's why I said it's more like, because that probably at the moment I wouldn't say that makes sense, but basically what you say, how is the road, how is the path, the request encoded? So the request is similar to, think of a NDS-like location reference, right? So it's similar, like we've seen things in OpenLR or so, similar to that, but it has additional NDS attributes piggybacked on the simply geometry and stuff. So yeah, but you would query for a larger part and not really send this every second or so. Yeah.
Okay.
Good. People are raising their hands. I want to be in the Q&A. So here we go. Let me add them. So you have to unmute yourself. I think everyone who joins there first is muted. So if you want to ask the question, simply unmute yourself and let us know. And for the ones that are raising questions in the Q&A, yeah, if you want to be part of the discussion, simply use the raise hand feature, and if not, then we'll simply pick them up and read them out.
So I think, can you hear me?
Yeah, we can hear you.
So in the same diagram, whatever you showed, so once if map tile is downloaded, you might not want to download the map tiles again. How we will come to know that whether map tile is changed or path is changed? So that only when it is changed, only we can download, or what was the main point we can say that map tile is changed or map tile is not changed, or a position path also changed?
Any of the other guys wants to answer that, or?
Maybe I can take this question. So for the tiles we have, let's say these tiles are static tiles. That means they might change on monthly basis, and we have the versioning info. So based on that versioning, we can query if we already have the latest version cached or not. If not, then we can make a request to send the latest version, or maybe even send the data only for that tile.
Okay.
While the speed limit layer might be a dynamic one that needs to be requested every time. It could be also even live, but then we don't need to retrieve or cache the whole tile again, but only the path with the related dynamic or live speed limit info.
Yeah. Okay.
It's something like that. I'm going to make the presentation in 2 weeks on the upcoming webinar regarding the whole concept. How does it work? I also try to show some proof of concept and demonstration how this concept can be realized.
Sure. And I have another question. It's not related. Where these recordings are stored? Where these Zoom recordings, whatever the recordings which is happening here, is stored?
Philip?
Sorry, we will post this recording online, so you can rewatch the whole session, and also the last session we did in early February, as well as the 2 upcoming ones. If you go to the NDS Association website, there's a news section where you will find links, and also the slides that we've presented are available for download then.
Sure. Okay. Thank you.
You're welcome. So I see Volker Hiestermann of TomTom, who we all know very well because he's very active in the NDS Association, has just said that he needs to drop. But he had a question, and I think I'll just read it off because it's an important one that a few people liked here. And he asked, when do you expect first product launches? From the HERE side, we're currently working actively with a couple of customers, and whether they're signing on with us or not, we're currently on a path to have an ISA NDS.Live service ready by late summer this year. So this is really live. And as I said earlier, we started developing in the joint NDS.Live development group together with Joinex, NNG, now Info. and here in the Electrobit last year. That work continues. So we're basically kicking our own tires and doing test drives with NDS.Live, developing services to see whether the specification works as it should and whether there's need to clarify things in there. So and that work continues. Good.
Oh, we have more guests on the panel here. So we have David and the other name I don't dare to pronounce because I probably do it wrong. So simply unmute yourself, ask your questions. We'll be happy to, whoever can go first.
Hello. First of all, thank you for a nice presentation. Quick question. So in my understanding, initial traditional NDS was not so good at handling scenario of streaming. And with NDS.Live, you overcome this obstacle and wanted to understand more how the inconsistency of tiles is addressed. For example, if I'm streaming some tiles that are not consistent with my previous tiles, is this addressed? Do you have some kind of consistency matrix that you take some tiles together? Thank you.
Yeah, maybe I can talk a little bit about that. Yeah, so indeed, this was a big topic in the design of NDS.Live to assist it for tile-based streaming. So one thing we did is making the tiles much more self-contained than they used to be. So one of the big issues you had with NDS Classic, if you wanted to do tile-based streaming, is the fact that you had all kind of hard references and dependencies on other tiles. And we worked on eliminating these as much as possible. So in your case, it's not really a matter of consistency matrix, but every tile is consistent by itself. And so when you are crossing, going from one tile to the other, you're not working with ideas that could be different or which could become dangling references, but you work with basically working on coordinate based on a tile. So you put nodes on borders and you match them based on geometry. And so in that sense, you never run into these, let's say, reference consistencies or dangling references or invalid references problem anymore that you used to have with NDS Classic. So yes, so that's basically what I try to do. It's all very modular and all very self-contained. Yeah. So basically, it could still be that when you have an old tile that you haven't updated yet, and you have a new tile, that it may contain a feature like a road that was opened, which is which doesn't have its counterpart in the other tile. If you don't update it yet, so you still need to have some buffer to overcome that you have the freshest data, but at least the inconsistencies that were specific in the NDS Classic format, these are resolved in NDS.Live.
Thank you.
And in case you already have a solution, a map streaming based NDS Classic solution for it, let's say for eHorizon, then it doesn't necessarily mean that you have to throw it away and completely switch to NDS.Live. Because the main approach of NDS.Live was also to reduce the migration efforts from NDS Classic to NDS.Live. So let's take this eHorizon and maybe the ISA use case. So we already have an NDS Classic based map streaming solution for eHorizon. You can still reuse it and use only the smart layer pass concept from NDS.Live. So that means the MPP calculation runs on an NDS Classic tiles and make a request to the NDS.Live services. Hey, I need some dynamic speed limits. Where do I get it from? So that can be used also for combining NDS Classic data with NDS.Live smart layer pass from dynamic speed limit. That's also a viable solution, and it reduces the migration efforts.
Thanks, Otto. That's also a question by Kostas here, who asked, how does NDS Classic and NDS Live work together? And I hope that answered your question, Kostas.
Okay.
Do you have more hand raises, Fabian?
We had Kostukin, trying now to pronounce that correctly. If you unmute yourself, please, you can ask your question.
Hi, everybody. Actually, I got an answer. My initial question was about how to sharing the path, calculated path between different services, more or less.
Mm-hmm.
And as I understand, it is about something about OpenLR, and client has to provide, I don't know, the full or piece of part in order to get piece of information along the route, right? Something like this.
Correct.
Thank you.
Right.
Thank you.
Okay, thank you.
So we have again some questions around how to get access to a specification or tools and so on. Maybe we can tell something about that. So in order to get access to the specification for non-NDS members, currently you have to sign an evaluation agreement with us. Maybe Philip, you can put on the slide again with the contact details of Marcus.
I will. A second.
So yeah, please contact Marcus Juncker from the NDS Association and request an evaluation contract for NDS Live, and then he will take care of that for you.
Yeah, that answers some additional questions here. Jürgen Terpe asks, can you please provide a link to the live lab? So that would be possible here. You get access to some sample data here. We have created a virtual island of data that is map data provider agnostic. So you can use that to do some first tests and evaluation. I think I saw another question here around data.
Yeah, there was one about the references, because we already talked about this. So Jean-François had the question between so how do we, if we have different map layers, how do we do references in between? So they're basically two ways to do this. So either they come in one smart layer package. So within one smart layer, we say, okay, this is one smart layer tile, for instance. There we are using direct ID, so there we have a certain consistent factor, right? But if they come from two different smart layer services, then they don't have this consistency guarantee. And there we're then using indirect references similar to the ones that we're using with the path. So you basically have to match it together on the client side. So hardwired identifiers only in the smart layer container, because there it's simply layers, but we already know, okay, they fit together. So the server basically gives the guarantee of consistency that this works. Hope this answers that question.
Is that similar to the question by Edward Mark here? I think it is, right? He asked, is NDS Live able to update its smart data services based on data generated by various transport agencies concerning dynamic roadway conditions, such as incidents and road surface conditions? And I think the answer is yes. Like, I mean, that's one of the principles as well, that we wanted to make sure that data providers who are not the big map data providers like TomTom here, Navinfo and AutoNavi and others, that they can provide their own data sets in NDS Live as an additional offering. And this can be, yeah, transport agencies, but it can also be a parking garage provider who offers indoor maps of their parking garages. Or yeah, other similar use cases. Okay, we have about 4 minutes left. So
maybe we can pass one interesting question we haven't yet answered, and it got upvoted. It's about the aspect of map data validation. How is this considered in the NDS.Live design? So talking about map data validation, maybe, I don't know, Boris, can you, I know that you're doing something or you're a little bit involved in that. Is that something you can answer?
Right. So in NDS.Live, we have a dedicated task force working especially on the validation and certification for NDS.Live. And so major difference between NDS.Live, one of the major differences is that NDS.Live brings not just data format, but also service interface definitions to how the car and the service communicate. So the validation aspect of NDS.Live then has to cover both of them. And this is where this task group is focused on. So how to efficiently validate and then also certify both a service interface as well as the data. So this is a work which we started some time ago. It has a certain complexity, and it has to perform well, and also conceptually has to fit well. So that the results of this work will, let's say, be reported a bit later, I would say, in Q2. We are still on a heavy discussion phase on it, but basically how it's going to work is that there will be similar to NDS Classic NDS validation tool, which will be able to run, let's say, on the backend side and make something similar like a classic approach in validation of NDS Classic databases, simply iterating through the tiles and running test cases. But also there will be aspect of the service and how does the service operate correctly as according to the NDS.Live specification. I think that probably there will be one of the webinars which are dedicated to this topic, right, Fabian?
Yeah, that topic can definitely fill a complete webinar.
Exactly.
So yeah, thanks.
What's worth noting here is that this certification tool is something that is provided to all NDS Association members, right? So it's not something that you have to develop yourself. In the past with NDS Classic, it was open enough to have a full set of validation test cases. You can also add your own if you have special tests that you want to do. But basically, the basic framework of that tool set is provided as part of the membership to all members.
I would like to pick one more question that was very interesting, but maybe that's like then the last, and that's the cliffhanger to the next webinar, which is Sebastian was actually asking, what is a typical cache size using NDS.Live ISA use case? So I think that's, first of all, hard to say right now. But I think Otto will, in 2 weeks, talk about how they did such an implementation. And maybe he can then, in 2 weeks, give more information about that or a small hint on what they did. So for that, I would say, since we're on time now anyhow, so that was the last question, maybe like, stay with us. We're not done. So Philip.
Yeah. Thank you all. I'm showing the slide again. If you want to request an evaluation license of the NDS.Live spec, please contact Markus Juncker. There were some questions around interface description, Zero, how can I get the protobuf format and things like that. Please get in touch if you're interested in the NDS.Live documentation. Markus Juncker is your man on our side, the NDS Association administrator, and his email is shown here on the slide. I hope you enjoyed our webinar about the advantages of NDS.Live, and I hope even more that you found this all useful and informative. If you've missed the webinar about the advantages of NDS.Live for intelligent speed assistance, then be reminded again that the slides and full recording is online already. This webinar was also recorded, and the video will be shared on the NDS Association website YouTube channel. Once available, we'll make a post on LinkedIn and on our website at nds-association.org. Please feel free then to share this with your colleagues and peers who couldn't attend today. And again, on March 11th, We'll talk about how to reduce data consumption in connected cars by using NDS.Live. Otto Miro will talk about this. And on March 25th, it's all about layering map data by Freshness in use cases and delivering them the smart way to cloud systems and vehicles with NDS.Live. Please join us again on these dates. You will find a link to register on the NDS.Live website. Thank you very much. Special thanks to all our experts on the panel and those of you who asked questions today. Have a great day. Thank you.
Thank you for watching. Visit our website for news on NDS at nds-association.org.